This video is on an introduction to acids and bases. So acids and bases have distinct properties, and it's one way we can tell them apart in the lab. So acids have a sour taste. So an example of an acid would be a lemon. Another acid could be Italian dressing, both of which are sour when you eat them. Acids contain hydrogen ions at the beginning of a formula. Acids will react with some metals to produce hydrogen gas, and they can react with bases to produce salt and water. This is a neutralization reaction. Because you neutralize the base with the acid. Acids are electrolytes because they are ionic and can conduct electricity. Acids have a pH less than 7, and an indicator we can use is blue litmus paper, and it turns red. Some other examples of acids include vinegar, milk, soda, apples, and citrus fruit. Bases have some of the opposite qualities. If you were to eat a base, it would taste bitter. It feels slippery. And these both describe soaps. Many soaps and detergents are bases. Bases are also electrolytes because they are ionic compounds. And they usually contain hydroxide. The exception is ammonia, which is NH3. All bases have a pH greater than 7. And here again, just like acids react with bases, bases react with acids to produce salt in water. A test with bases is they can turn red litmus paper blue. They also phenolphthalein turns pink in a base. And we'll use that later on in this unit. Some other examples of bases, like we said, was soap, ammonia, and detergents. Acids and bases can also be broken into different types of acids and bases in addition to their physical properties. We can have Arrhenius acids and bases, and these were the first ones to come about, the first categories of acids and bases, and it's dependent upon how they dissociate into ions in an aqueous solution. So acids are going to dissociate into hydrogen ions. And bases will dissociate into hydroxide ions. So an example of this would be hydrochloric acid, HCl. That dissociates, so breaks apart in water into hydrogen ions and chloride ions. The chloride ions are neutral. The hydrogen ions, this is the acidic portion. That's what causes it to be an acid. Bases, an example of a base would be sodium hydroxide. When that dissolves in water, it dissociates into sodium ions and hydroxide ions. The hydroxide ion portion, that is what tells us it's a base. We can have things that act as both an acid and a base, and those are considered amphoteric. An example of this is water. We typically write water as H2O, but we can write water as HOH. So when water goes into and breaks apart, we see our hydrogen ion and our hydroxide ion. So that can react with different things to make our acids and our bases. Another example, or another type of acids and bases, are the Bronsted-Lowry acids and bases. Bronsted-Lowry acids and bases are based upon how the hydrogen acts. So depending upon who has the acidic hydrogen, and this is considered the acidic hydrogen, where that is and who has it determines who is the acid or the base. Acids are going to donate the hydrogen ion. The base is going to accept the hydrogen ion. We can then make a conjugate acid. So the acid that was made is the product that now has the hydrogen ion. And the conjugate base is the product that lost that hydrogen. So an example of this is sulfuric acid and water. Sulfuric acid, H2SO4, reacts with water. And what happens is one of these hydrogens from my sulfuric acid gets donated to the water. So our products are HSO4 minus, because it lost that hydrogen, plus H3O plus, because this water has gained the hydrogen. So sulfuric acid lost the hydrogen. That makes it my acid. Water accepted the hydrogen from sulfuric acid, so that makes it my base. My acid over here was the product that lost my hydrogen, so that makes it a conjugate base. And here, my product that gained my hydrogen, that's my conjugate acid. So we have acid turns into a conjugate base. We've made it more basic. And our base, except the hydrogen, becomes a conjugate acid. So we've made it into an acid. We'll notice that here, sulfuric acid has more than one hydrogen. It's considered polyprotic. I have multiple hydrogens. And that depends upon the charge of the anion portion of my compound. Monoprotic means 1, diprotic means 2, triprotic means 3. And we can classify the acids accordingly. We can also classify acids by their strength. We have strong acids and bases and weak acids and bases. Strong acids and bases are going to ionize in water 100%. So it's going to completely break into the hydrogen ions, and the hydroxide ions are going to completely break apart into solutions. That makes them strong electrolytes because we have lots and lots of ions floating around in our solution. Some examples of the strong acids: hydrochloric acid, nitric acid, and sulfuric acid, hydrobromic acid, hydroiodic acid, and perchloric acid. Some of the strong bases are sodium hydroxide, potassium hydroxide, calcium hydroxide, and barium hydroxide. If we look on the periodic table, we'll notice that our bases kind of make a chair across, and it is considered the chair of bases. Weak acids and bases only partially ionize in water. So they do not ionize completely in water. They're considered weak electrolytes because they only kind of conduct electricity. Some examples of weak acids are hydrofluoric acid, acetic acid. This is found in vinegar. Phosphoric acid, carbonic acid, and hydrocyanic acid. The weak base we're going to refer to is ammonia. And this is the one base that doesn't have that hydroxide part to it.